All right, I'm going to get started because otherwise we might run out of time. So, good morning, everybody. My name is Wim. I work for Leers. I work for Acquia. I'm working on the Spark team. And Spark team is about improving authoring experience and so on in Drupal 8 and also in Drupal 7. But it doesn't mean that we work just on that. We also work on making Drupal 8 in general better. So one of the things I worked on as well was improving Drupal 8's performance. I'm a speed freak. I really like making things fast. So I just want to share today a few of the interesting things or things that I found interesting with regards to performance that are changing in Drupal 8 or getting better in Drupal 8. So hopefully this will make your lives a little bit easier, your sites faster, and your sites a little bit more scalable. So this talk is about a few things. What Drupal 8 does better, render caching, which already existed in Drupal 7, client-side caching, pluggable CSS and JavaScript optimization, and things that really still need to happen. So let's get started with the simplest thing first. Due to my studies, my personal blog was still on Drupal 5 when Drupal 7 was already around for a long time. So at one point in 2011, I wanted to upgrade from Drupal 5 to 7 and skip Drupal 6. And since I care about performance, since I'm a speed freak, I wanted my site to be very fast. So I worked on various optimizations, integrate with a CDN, make sure that no obsolete or rather extraneous CSS was being loaded on every page, and so on and so on. But while working on that, I was very, very surprised to find that every single page in Drupal 7, every single page, no matter what you do, will always load jQuery.js, Drupal.js, and Drupal.settings. And that's really a big problem. So that's the title of this slide, load JavaScript on all the pages. That's what Drupal 7 is actually doing. And that's fortunately not anymore the case. And it's fixed in Drupal 8 because of a few things. The two most important things of which are we're now declaring all dependencies. So you're always using a library in Drupal. And you're always saying this library, this combination of assets, depends on this other combination of assets. And one other thing that's really important is that we're no longer using Drupal add CSS, Drupal add JS, and Drupal add library. We're only using bound attached to ensure that assets that belong with the content are loaded. And sadly, this is an unfixable problem in Drupal 7. I worked on trying to get it fixed back in 2011. The only way you could solve it is actually by hacking core. So it's really not there is no way to solve it. I'm not sure if he's here today, but Peter Droogmans from Ethics, he's bravely working on trying to figure out a workaround for Drupal 7, but in any case, it's going to break API compatibility. So it would be a flag that you could enable in settings.php, and then maybe you could have the same behavior as in Drupal 8, but that really means that it's only fixable for individual sites, because any contrib module is going to assume that jQuery.js, Drupal.js, and so on are being loaded already. So let's see how it works in Drupal 8. Everything I'm showing here can actually also be done in Drupal 7 in the next few slides. So, for example, if we look at TABLESELECT.JS in Drupal 8, then we see, let me try to select there. We're using Drupal, and we're using jQuery. So those are the two things we're using. And whenever you use something external that is not inherent to the JavaScript language or of the DOM, then you should always import it through a closure. And by doing so, we're protecting against multiple, for example, it used to be the case that multiple libraries would like to use the $sign. For example, jQuery would like to use it, and I think Prototype or something would also like to use it. This is where it originally stems from, but it's also a nice way of showing explicitly, this is my logic for JavaScript. These are the external libraries I'm depending upon, so I declare them explicitly. So you put them in the closure. Next, that was the JavaScript side. Next up is the PHP side, and there we want to declare a library. A library is a combination of assets, CSS and or JavaScript, and there too we are declaring our dependencies. So we use jQuery and Drupal, so we're declaring them there as dependencies again. So jQuery and Drupal were in the closure, hence you should also declare them as dependencies. Next up, abandon Drupal add CSS and JS. And instead always use libraries, but in fact also abandon Drupal add library and attach it as a library. So I'm pretty sure that most of you have seen this before, if I can find my mouse cursor. So you attach, what do you attach? A library. So why is this the case? Why is it really important to use attached? Well, because Drupal adds CSS, JS, and library all work through global states. What's happening is, while the page is rendering, you make these many calls to Drupal add CSS, JS, and library, and it's keeping track of which files, which assets it should attach to the page in this global state. But the problem is, if you cache anything of the content, for example, a specific block that needs foo.css, and if you add foo.css through Drupal add CSS, it's in global state, but when you have cached the content of the foo block, this function will not be called again, because the whole point was to make things cheaper by caching the entire render array. So by making the assets declared through attached, you're making the assets that you need part of the render array, meaning that when it's cached and retrieved from the cache, Drupal knows, hey, this is a CSS file that was needed for this piece of renderable content, so let's load it again. So it's really important to not use Drupal add anymore. So conclusion for asset loading is you should load assets by attaching libraries, and it results really in a better DX because there's far less magic going on. Did the mic? Okay, weird. So much less magic going on because there is no global state anymore. Everything is declaratively in the place where you're declaring your content as well. The result is that you have actually renderable cache arrays, which wasn't the case before. Only the required assets will be loaded because in the case of Drupal.settings in Drupal 7, that will not be loaded anymore automatically. What you have to do is declare a dependency on Drupal settings, and then Drupal settings will be loaded. And as well, when you dynamically load content, as in Ajax in content, thanks to declaratively declaring which assets you want, you won't have duplicate assets being loaded anymore, which is sometimes the case when using the Drupal add functions. So, attaching libraries. And as I alluded already, this is also something that was kind of incompatible with render cache. So using Drupal add star was incompatible with using the render cache precisely because it was tracked in global state and not part of the render array itself. So it's also one of the things that was blocking render caching of entities, so nodes, users, taxonomy terms, and so on. And it's also in Drupal 8, rendering has gotten a lot more expensive of entities because there's so many more abstraction layers and things are getting better, but it's probably going to be the case that we can only improve performance of Drupal 8 when rendering entities versus Drupal 7 if we get render caching to work. And we're almost there. But before we got there, we had to do quite a lot of things, and this is just a very small selection of it. We had cache tag support, which I will explain in a few seconds. But it's useful for many things, not just for render caching. Contextual links, the way it worked in Drupal 7, was fundamentally incompatible with render cache. The comment new indicator, which I'm sure all of you know, which is very handy, and that was even more fundamentally incompatible with render cache. So these things were all part of the entity render array, but they were really incompatible with what the render array would have to do. So that brings us to this nice quote that probably most of you have already seen at some point. Cache invalidation, that's the really tricky stuff. Filling caches is super easy, right? You make an expensive calculation, you store it somewhere, and you retrieve it at some point. But determining when the proper time is to invalidate that cache, to delete it from the cache, and to regenerate it again so that you don't regenerate it over and over again, hence not really making effective use of your cache, that's a tricky part. So having poor cache invalidation, which was the case in Drupal 7, as we will see in a second, that's just leading to poor performance. So first we want to make sure that Drupal's cache invalidation is sufficiently good, and then we can make sure that we fill the cache correctly. And before getting to that, I just wanted to add one acronym, P15N, like I18N for internationalization, P15N for personalization, so that my slides aren't filled up with that long word. So cache invalidation, it's really hard, or it can be really hard. Probably most of you have seen this screenshot or this particular setting on the performance settings page, cache pages for anonymous users. And probably quite a lot of you have enabled that at some point or have enabled it today. And you may be surprised to find out that that is not very effective at invalidating caches, because if any node is edited, if any comment is edited, any of those simple things, and all content that is cached, all cached pages will all be cleared. So even the most simple operations on your website will make this cache a lot less useful, because everything that is cached on your site, maybe thousands of pages, are all cleared if just a single thing is edited on your site. So that's pretty, whoa, what? So cache clearing in Drupal 7, how did it work? You could clear a specific cache entry if you specified a cache ID in a specific bin. You could clear a coarse set of cache entries, meaning you could specify a prefix, so every cache ID in your cache bin that matched this prefix would be deleted. So that's a way of deleting or clearing a cache in a partial way, but not in just a way of deleting one cache entry. And then there is a way of clearing the entire cache bin, which is, of course, super coarse. So the question is, if you edit node 42, how can we clear just those cache entries that contain node 42? Well, with the tools that we have in Drupal 7, we just can't. So yeah, Drupal 7 couldn't really do better. And that's why in Drupal 8, cache tags are so exciting. So in Drupal 7, you would have cache underscore sets and something like the parameters here. In Drupal 8, it looks like this. You open a cache bin and you set a value with a certain cache ID. You, in this example, cache it permanently, meaning that it won't expire automatically. And then you specify the cache tags. That's the interesting part. So something in the page cache would have the cache tag content. Something that is HTML that contains maybe the node title of node 42 would be tagged with node 42. And the really interesting stuff is when you have something more complex, like a full node that is being rendered, that has two taxonomy terms. A node has a node ID, so the node is tagged, cache tag node 42. A node also has an author that is usually displayed within the rendered node. But if the user's name is changed, then each rendered node that is written by that user should also be cleared, right? Because otherwise the username is outdated. So we also tag it with user 314 in this case. And then there's taxonomy term references. If you tag a node with certain taxonomy terms, when those change, when their names change, then again the cache entry should be deleted, right? So we tag it with that as well. And what this really means is every cache entry has a set of cache tags, the ones you can see here. And now we have an ability to clear just based on those cache tags. So we don't have to specify a prefix, which can be arbitrarily complex because contract modules can do whatever they want. And now we can clear caches based on cache tags. I'm not sure what's going on there. I just showed the equivalent of cache underscore set in Drupal 8, but we can also use cache tags directly in render arrays. So in the example here, what we have is you specify cache keys. Those are the things that will make up or determine what the cache ID will look like, so it's generated automatically for you. The granularity also contributes to that. And then there is this thing, just cache tags, again, that you can specify. So by using this approach, in combination with something else that's really important, because as you can see in the above example, there's only the entity type that is expounded to node in our example, and entity ID is node 42. So node 42 is tagged, but what about the user? What about the taxonomy terms that I just showed in the previous slide? Well, this function, Drupal render collect cache tags, is going to go into the render array and look at not only the main element, the root element, which is the entity, but also the child render arrays. So the username reference, the taxonomy term references, and so on, and collect their cache tags as well and move it up to the upper level. So now the eventual cache render cache entry is going to contain all the identifiers for the content that is referenced somewhere within that render array. So the idea is that you now get a reliable way of knowing which things, which content that is interesting is is included in the render array so that we know when to clear it and only then clear it instead of clearing everything. So essentially this is what solves render caching in Drupal 8. And now we also have two ways of clearing caches. So before you had cache clear all and then specify a bunch of parameters, but it would always imply deleting the cached stuff immediately. But now in Drupal 8 you have two ways of doing it. You have delete tags, which means anything that is tagged with these tags, deleted from the cache bins immediately, and it essentially prevents stale content, so that you cannot ever have content that is slightly outdated presented to the end user. But there's also now invalidate tags, which just says, hey, this content is not really up to date anymore, but if you really want to, you can still use it. So that might be interesting in some use cases. So this is the alternative that allows for stale content. So depending on your scenario, you can choose either. So you have more flexibility in clearing as well. So cache invalidation seems like we got that working. So the next thing is caching itself, which seems easy, right? Contextual links in Drupal 7 look somewhat like this. So in the top right corner, you have operations that you can apply to the node. And the HTML to go along with that, it looks something like this. So you have a div in which there is a bunch of links, and those links even contain the destination parameter. Right there. So effectively they are page specific, and these links also determine on which permissions the current user has. So contextual links are part of a render cache entry, for example, in this case of the node. The node contains things that should only depend on things like user, taxonomy terms, and so on, but effectively by using contextual links in this way, we are making sure, or we're causing the cache entry to be specific to the current page. So we really can't use the cache entry anywhere else except on the current page. So that's not really efficient caching at all anymore. So we also have to be careful to not put personalization or contextual information into the render array, because otherwise our cached render arrays will be completely useless. So what's happening here, we've embedded in the node's HTML the eventual personalization stuff, and it's adapted to the user permissions and the page, and that effectively breaks the render cache. In Drupal 8 it works somewhat differently. What we're doing is we're adding in an invisible placeholder, a div that doesn't show up, and the div contains an identifier. And again, it's embedded in Node's HTML, but it's an invisible placeholder, and it's a very important difference with what's there before. Because since it's an invisible placeholder, that is true for everybody, because the identifier is just saying you can retrieve or build the contextual links based upon the ID that's stored in there. And that's true for everybody. You can even serve it to anonymous users, and anonymous users can't do anything with it. So instead of having user or role-dependent cache entries and even page-dependent cache entries, we now have a single cache entry that we can reuse everywhere. So that's a really important difference. We have to make sure that all things that we put in the cache are as much reusable as possible so that we have less duplication and more efficiency. So the logic in general of how that works is you have the contextual IDs in the HTML, you combine it with some JavaScript that is only added if the user has permission to use contextual links. The JavaScript then looks at the HTML, figures out which the contextual IDs are that are stored in the invisible placeholders, posts that to the server, gets back corresponding HTML that renders the contextual links, and the end result is that we have the same HTML for all users, because personalization is applied only later on. And another example is a new comment marker, which I already said before that was really problematic. So before we would render it, if you look at the div at the top, it would calculate for the current user whether the comment was new for that user on this page load, because if the page was reloaded, that would no longer be true, since looking at the page itself makes Drupal assume that the comment was read. So every single page load had to do these kinds of calculations for a lot of comments. And what we're doing now, again, is the same technique. We're applying a hidden placeholder. So a span class is hidden, makes it hidden, and a data attribute that contains the timestamp for that specific comment. Then there is a hook that inserts the node ID. So a comment is always within the boundaries of a node. So you have the node div essentially, and there we attach the node ID in a data attribute, and then within the node there are a bunch of comments, and those comments contain the comment timestamps. So there's all, again, universal truths in there, things that are not sensitive. Anonymous users can see it, that's fine. Anonymous users don't have the new marker functionality because nothing is stored for them, but it's safe to provide them this metadata information anyway. So again, something is embedded in the node's HTML. It's again an invisible placeholder, and thanks to that, it doesn't break the render cache anymore. So same technique. And here it's also again very similar. We have the relevant information embedded in the HTML, some JavaScript that is added only if the user is authenticated. Again, we go to the server to retrieve the node timestamps in this case, so we don't retrieve a bunch of HTML, we just retrieve the timestamp for the current node, for the current user. So it means we ask the server, hey, I am user X and I'm looking at node Y. What's the last time I've read this node? You get back a timestamp, and we can then compare that with the timestamps that are embedded within the data attributes of the comments. And then we can just calculate on the client side, hey, this comment is new for the current user, this comment is updated for the current user, and so on. So we move the complexity from the server side to the client side. And again, same HTML for all users, and personalization applied later on, thanks to JavaScript. And we kind of repeat the same stuff for the tracker new and updated markers and the X new comments links when you look at a node's teaser. In Drupal 7, in general, user-specific data in the HTML. And in Drupal 8, we do things differently. We added data attributes or multiple data attributes with universal truths that are not sensitive, that anonymous users can access as well without problems. Perhaps on invisible placeholders, perhaps somewhere else. JavaScript is loaded if the user has a permission, and we cache user-specific data on the client side, and only if necessary, we talk to the server. So the conclusion is, always use cache tags precisely, because if you don't, then you don't have granular cache clearing, and the end result is you don't have efficient cache use. You can delete tags to prevent stale content, and you can invalidate them to just allow for stale content and leave it up to the code to decide whether to use the stale content or not. And in terms of cache filling, you should personalize via JavaScript and cache on the client side to ensure that you have cacheable render arrays. It's totally safe to embed universal truths as data attributes, and personalization should happen through JavaScript and local storage. And you can do all of this in Drupal 7 as well, to some degree. So most of this you can perfectly do in Drupal 7. The only limitation is that you don't have cache tags. So you cannot efficiently clear cache entries. That's the big problem. So render caching, if we have used efficiently, it can give a very big performance boost. Now, as I already mentioned, client-side caching. You may be thinking that I made Drupal slower by moving a lot of things to the client side, because now instead of having one HTTP request that returns HTML generated by Drupal, it contains all the information your end user needs, we're now making that initial HTTP request faster by not doing personalization yet. But then the client side, the browser of the user, has to make multiple HTTP requests for each personalization thing. So in current Drupal 8, we actually have separate requests for the toolbar. So the toolbar in Drupal 8 shows an entire menu tree that is retrieved separately to not slow down each page load. We have the comment new markers for which we may need to make an HTTP request. We have the contextual links that need to be rendered through an additional HTTP request, and there's in-place editing as well. So it seems like we made Drupal go from 1 request per page load to 5 requests per page load. And that's pretty bad, of course. But really, our goals are to make Drupal more scalable, meaning more requests served per second, but also to make Drupal have a better perceived performance. So we really shouldn't be looking at number of HTTP requests only, but making sure that Drupal feels faster for the end user, and not in terms of requests per second, but really feels as in everything is loaded. That's what's really important. And what we're doing here is we're doing that by serving the HTML faster, since we don't need to personalize on the server side anymore. We're personalizing through JavaScript and then caching on the client side. And what it effectively means is will always have, a faster time to glass. Time to glass means user requests a page and the time it takes to have something rendered on the page, as in the time it takes until the header is visible, for example. And the reason it's always going to be faster is because there is no personalization anymore. Pretty much everything besides the Drupal settings array that contains the user ID and, for example, the current path, those things are request dependent, so we cannot cache them in their entirety, at least not for authenticated users. But overall, most of the things, if we cache them efficiently using the render cache, then that means that pretty much everything on the page is in the render cache, which means we can answer every request much faster. So the idea is to making sure that the user always gets the HTML faster, which means that the browser can start looking at the CSS and the JavaScript in the top of the page immediately, or rather much faster. So that things are loaded much faster, because right now maybe Drupal takes 0.3 seconds to generate the entire page, or 0.5, depending on how complex your site is. And only then it starts sending the data to the browser. But if we can make that faster, as in if we can cut a lot away from that and get the HTML to the browser faster, then the browser can apply its algorithms to scan for assets much faster, which means that the entire page will load faster. You will see something much faster. So faster time to glass, move personalization from the server to the client. And personalization on the client then, yes, it's going to be slower if the cache is cold, because that would indeed require 5 requests. But it's going to be much faster if the cache is warm, because there will still only be 1 request for the HTML itself. And why is it going to be faster? Because there's far less data to calculate on the server side. There is far less data to be sent from the server to the client, because most or many important or expensive things are already cached on the client side. The client doesn't need to retrieve anything, it's just already cached. So the gist of this is, when you serve an HTML skeleton, because the personalization stuff is still missing, but in most cases of Drupal there is rather few things that are personalized. The majority of the page is still the same for everybody. So if we serve the HTML skeleton and then apply personalization through JavaScript, that's going to be faster, as long as our cache, our client-side cache, is warm. And another thing that is really important to remark upon is the more personalization you add, the slower things are. Whether it's calculated on the server side or the client side, doesn't really matter. It's going to be slower, because more things have to be customized, and we cannot just send pretty much the entire same page to all users. So it's more expensive by definition. And I think many of us in the Drupal world have forgotten that a little bit, because the comment new marker, for example, who doesn't assume that that is there, and who thinks about the cost of that? But there is a cost to that. So I think in general we should pay more attention to making sure that everybody gets the same stuff, and really weigh the benefits and downsides of adding personalization stuff, even something as simple as a new marker. So the real question is, how to keep the cache warm, because as long as it's warm and cozy, the client-side cache, things should be faster. And that actually brings us back to the same quote. Cache invalidation is hard. Cache invalidation on the server side, in terms of render cache, is hard. But it's also hard on the client side, because we have to make sure that the client-side cache is warm as often and as long as possible. So how do we invalidate it efficiently? One example that we've been working on is the toolbar. So that's, in case you hadn't seen it yet, in Drupal 8 is what the toolbar looks like on a mobile device. And the menu tree on the left-hand side, that is the part that that is causing, at this point, still 1 HTTP request per page, and it's not client-side cached at all yet. But the patch that is mentioned there in the issue number on the slide is making sure that that HTTP request is going away and is being replaced by simply 1 setting per page. So 1 tiny setting per page instead of an additional HTTP request. And the way we're doing it there is we're using hook page build, which is kind of like hook init in Drupal 7 to attach stuff, for example. So in this case, we're attaching a hash. The hash is an identifier of telling to the client, hey, this is the version that you should be having, a hash of the data it should have. So if the hash changes on the page that the client receives, then the client knows, oh, my client-side cache copy is outdated, I have to get a new one. So the hash is the thing that communicates to the client when it should update its cached version. And the hash depends on a lot of things. So it changes whenever a role's permissions change, whenever a user's roles change, whenever any menu link in the admin menu, because that's the menu that was on the left-hand side on the phone just now, when any of those links change, for example, their name is changed or they are disabled, or whenever any module is installed or uninstalled. Any of those things happen, and the hash should be changed. So that's what it looks for. It implements hooks to listen for those things. And what it then does is, on the client side, it does something like this. And let me see if I can select things again. Okay, so ls is the way I shortened local storage. Next is, let's assume we're on the client side and we're loading this menu tree on the left-hand side. What we're doing is we're looking first at the hash that is on the current page. So we're looking at Drupal settings. It's now Drupal settings, not Drupal.settings in Drupal 8. So Drupal settings.toolbar.subtrees hash, that's where our hash is stored. Then we retrieve the hash that we stored previously in local storage. So local storage.getItem, and we get the subtree hash that was cached. And as long as they're identical, so we compare for identicalness, and if that's the case, then we can just retrieve it from local storage, the cached version, parse it, we have the subtrees completely, and we just load it. Nothing happens with regards to going to the server. It's a lot cheaper too, because it's a pretty big chunk of HTML, the entire menu tree. So instead of having to send that with every page load, even as part of the main HTML, so that you wouldn't have an extra request, this is much faster because it's already on the client side, so we don't have to send it at all. And clearly, the admin menu tree doesn't really change that often. I can imagine that it changes often for you. So it should be on the client-side cache for a long time, so making things faster for a long time. Now, if it's not in the client-side cache, we just remove the cached copy. We do an AJAX callback to retrieve it from the server, and then we remember the new hash, so that we can again make the necessary comparisons there. So that's overall how it works. It's pretty simple, right? Another example is the new common markers. What we're doing there is we're not really making a request to the server every single time we load a page. We're trying to be smart about it. So what we do is we store the last read timestamps. So the last time the current user read that node, viewed that node, is stored in the client-side cache. We key that by user ID, and it's really the minimum last read timestamp, because maybe it's outdated, maybe not. But the thing is, it doesn't ever change in the sense that if you once read a node, for example, 2 days ago, then you're not going to have not read it today, right? You may have read it again today, but you would still have read it 2 days ago. So if every comment is older than 2 days ago, then we know enough already with the data in the client-side cache, because every comment is older, hence we've already read them. So we can a little bit smart about that, thanks to the simple fact that what has been seen cannot be unseen. So no hash is necessary in this example. So what's really happening is you should use heuristics to improve your specific use case. Ideally, we would have many more hashes to do smart client-side caching, and we currently have only the user ID. That's the only thing we have. And the toolbar is doing something custom, but the user ID is added always. We're probably going to have a permissions hash to do client-side caching of permission-dependent data, for example, for in-place editing, for example, for contextual links. And hopefully there will be many more, because then we would be able to do more client-side caching, and not every contrib module has to invent their own stuff. So a conclusion for client-side caching is you should cache slowly changing data, in the sense that if your data is changing every single second, because it's tracking the stock exchange or something, yeah, you shouldn't cache that on the client side, because that doesn't really help you. Usually it's used for personalization stuff, but you can use it in general for anything that is expensive to either send, because there's a lot of bytes to be sent, and that's expensive, especially on mobile devices, because 3G is very slow, or anything that is expensive to calculate on the server. If it's cheaper to just move that to the client side, just do that. Another very important thing is when you do client-side caching, you keep the cache warm, because otherwise it will be slower. So generally, you should minimize the number of requests, and you can do that in 2 ways. You can apply heuristics. For example, in the case of the new marker, what is happening there is anything that is older than 30 days, Drupal assumes that has been read already. So if you have a node from 30 days ago, or let's say you haven't visited a Drupal site in 2 months, then any content older than a month ago that you haven't seen it usually would have the new marker on it. It won't have the new marker on it, just because Drupal just says, I can't track everything for you. I just keep things simple and only track the recent stuff. And the other way, so one is heuristics, just try to optimize away and not do too much work. The other way is using hashes, which is kind of like client-side cache tags, which you can send to the page, to the JavaScript through Drupal settings. Then the last big thing, you can optimize away all the necessary bytes if you really like that, and I personally really like that. So CSS and JavaScript aggregation, that's what this really is about, CSS JavaScript optimization. In Drupal 7, the API, which is a very, very euphemistic description in Drupal 7, consists of these two callbacks, the aggregate callback and the group callback. That was it. And there was no documentation, and if two modules that implemented both, it would kind of work in an undefined way. So that was not great. So you could overwrite the whole, as in implement both callbacks, or nothing, and just deal with it, or apply hacks. And hacks is what most modules that did something in this area did. So an example is the CDN module would have to override CSS aggregation because Drupal CSS aggregation doesn't include the protocol. So if you distinguish between HTTP and HTTPS and you have an HTTP CDN and HTTPS CDN, Drupal just generates one set of aggregates, and depending on which one, which the request was for which the aggregate was generated, it would be served to everybody, and then things break horribly. That's one example. The Omega theme also does things there. And the end result is that you have really incompatibility hell, because every module hacks things in a slightly different way, and then, yeah, things break horribly. So in Drupal 8, what we're doing is we're making the API far more explicit, and make sure that you have more building blocks so that you can choose more specifically which things you would like to improve, which things you would like to override. So the thing is, we actually didn't change the aggregation, the optimization of assets at all. It's identical. The only thing was we restructured it so that you can choose which parts to override. And this will look very boring, and it is, but it's also interesting. So it essentially consists of a bunch of interfaces. The asset collection optimizer interface. So effectively that would mean a collection of CSS assets is passed into this, and then you can optimize them. It returns again a collection of assets, namely the optimized ones. The next thing is an asset collection grouper interface. This is the thing that the collection optimizer calls to decide, hey, I have 30 CSS files. Let's group them in a smart way so that we have fewer requests to deal with. So for example, it would group them into 3 different groups, each consisting of 10 CSS files. Then there is the asset optimizer. Each asset is loaded, so each of the 10 CSS files per group is loaded, is optimized, and is concatenated. And the eventual end result is dumped, is stored somewhere. And finally, when the asset collection optimizer, meaning the thing that optimizes the 30 CSS files, which returns 3 CSS files, when that is done, it still needs to be injected somewhere in the HTML. So the asset collection renderer is what makes it possible to transform that set of assets into a render array that Drupal can deal with. Now, the cool thing is that you can override anything at will. So at the top we have the CSS collection renderer, then we have the CSS collection optimizer, and so on and so on. The same stuff, analogous stuff for JavaScript. And these are services in Drupal 8. So this is a services.yaml file, and you can just override any of these individually. And it's really, each of the things listed there is just a class. So it's nothing huge, complex, or whatever. It's a single class that just implements one interface. That's it. And the possibilities here are really cool. So one example is the asset dumper. You could override just the asset dumper service, and instead of having them write to local disk, you could have them write to an external server like a CDN or to S3 or have a custom directory structure, whatever you want. You can have a JavaScript optimizer that is custom because the one in Drupal core essentially does nothing. It doesn't optimize your JavaScript at all. So if you're a hipster and you're using Node.js and you install Uglify.js to optimize your JavaScript, you can do that and just plug it in, just write a single class and you've got it up and running. Everything else remains the same. You just override this one component in the whole. Another example is you have a JS collection renderer that you want to use to make sure that the lab.js script loader is used. You could do that as well, and everything else still continues to work the same as before. A really cool thing is you could plug in to a third party that does data mining that calculates globally optimal groups so that every combination of assets is truly globally optimal, meaning that you're minimizing it for the entirety of your, for every visitor. It's optimized in such a way that he or she does as few requests as possible, yet still efficiently deals with things. Another example is collection optimizer. So each of these things listed here is a separate component. So you just pick one, well, a service. You just pick one service to override, and then you can just improve the hell out of that one service. The collection optimizer, you could override that as well. For example, you could make it so that whenever any file changes in the asset collection, you automatically generate a new aggregate, which in Drupal 7, the only way you can develop against Drupal 7 is to have aggregation disabled, because otherwise new stuff isn't picked up. This could make it so that you could have aggregated stuff and still be developing. And it's also possible to just use not any of these services, or rather, not using all of the services, but just implement the service that is the entry point, the collection optimizer, and just change that completely, and then you can use your completely custom architecture. You don't have to use the asset dumper, the JS optimizer, and so on. You can just completely change how assets handling works. So conclusion is, you can override individual asset services. You can improve individual ones and use the existing architecture, or you can just apply your own architecture. In Drupal 7, this was an impossible thing to do. So that brings us to the end, and what still needs to happen is quite a lot, but at the same time, we're getting there. Entity render caching is not yet done. It's almost there, but it's not yet done. It would be very cool if we could have cache tags implemented for views, because then views could be cached much more efficiently and cleared, and most importantly, invalidated much more efficiently. We could have CSS and JavaScript aggregation enabled by default, making every Drupal site fast out of the box. And if we get that permissions hash implemented, then we can remove 2 HTTP requests, one for contextual links and the one for edit. So that removes 2 HTTP requests per page. And in general, you can, if you look at the Drupal issue queue, then you can look at any issue tagged with Drupal 8 cacheability. So, quick recap. Loading assets by attaching libraries. That's the way you should do it, and that's the way you can already do it in Drupal 7. If you do it that way in Drupal 7, you can easily update that code to Drupal 8. Use cache tags precisely if you want cache invalidation to work efficiently, and personalize through JavaScript and cache on the client side, because otherwise your render arrays will not actually be cacheable. Client-side caching, you should always cache slowly changing data, which is relative, and you should keep the cache on the client side always warm if you want things to remain fast. Asset handling is much better in Drupal 8 because of a more refined architecture, and you can override individual things, so depending on your needs, you can override one thing, 2 things, or everything. Things that still need to happen, would be great to see you there, and help review things, test things, because you can really make a big difference in making Drupal 8 a lot faster. Not just Drupal 8 out of the box, but also make your lives easier when developing with Drupal 8. So that was it. Hope you liked it, and if you have any questions, speak up.
If you define your own pages by code.
By what?
By code, by PHP. How do you define when it should be, when the page
So the question was, if you have a page defined in code that contains certain content, how do you define when the content has changed and it should be invalidated? That's the question, right? Yeah. So if the page is defined in code, does that also mean that the content is in the code? If so, then you don't have a lot of benefit by using render caching, I think, since it sounds like you're just returning an HTML string. But in any case, if you have content that is retrieved from somewhere in the database in Drupal, then it's really up to the thing that is changing that content. So for example, if you have a node and you're modifying that node, then you could, in the submit handler for the form to edit the node, you could invalidate the corresponding cache tags. So that's the way you can do it in general. Does that answer your question?
Are there specific hooks in Drupal to invalidate cache? Nodes or like that?
I don't think there are specific books about this, but I'm pretty sure that there are chapters in Drupal books that deal with this.
I'm still not used to the new way.
The new way, the Drupal 7 or Drupal 8 way? I'm not sure what you mean.
I know Drupal 4 to 7.
Okay. That's a pretty big difference. Any other questions?
A lot of people are just going to be kind of end users or administrators of Drupal. And so in Drupal 8, if they're the kind that just want to check one checkbox to say, cache whatever, how much will Drupal 8 improve over Drupal 7 to the out of the box?
That's a very good question. So the question was, is there going to be a checkbox like the one in Drupal 7, cache for anonymous users? And is that going to work effectively? That's the question, I think, right? Yeah. Okay. So the funny thing is, the problem I described with Drupal 7, as in the checkbox on the performance settings page, and how it didn't do much useful anyway, because Drupal 7's caching system is not precise enough, not flexible enough. The thing is, in Drupal 8, we have all the tools we need to make it work in the way I described, so that it indeed works smartly and will only clear the cache entries that are actually affected. So if you edit node 42, only node cache entries containing node 42 will be affected. But it's not yet implemented. So that particularly page caching is not leveraging that yet, and it's still implemented in the dumb Drupal 7 way. And I actually discovered that while working on this presentation, so I plan to work on that in the next few weeks. So if you want to help with that, please contact me. Any other questions? If not, thanks. Bye.